Deliani Cinciella, what's up, YouTube? Psychic trauma here, hashtag living the stream. Um, yeah, alrighty. Yeah, we got audio going. No, let's get our fucking, what do you call that going? A compTIA. Don't need this. Alrighty. Um, present screen. Share screen. Share screen. Oh, there it is. Alrighty, here we go. It's like 90 something degrees today. Went into the river. When I came back, I passed out for a couple of hours. Nice. Woke up, I think, at like 9 something. Don't really remember. And then what do you call it? Watched a little YouTube. I've probably been up for about an hour, I'm guessing. Watching TV. And I was like, man, I got to get after Security Plus stuff. Here we are. It's Friday. We'll go out and do a live stream. Oh, got to get a whole bunch of shit organized. It's the weekend. Oh, I got to clean my bathroom. Yep. Once a weekend, right? Taking sweet ass time to load up. Yep, here we are. Yeah, I got to get rid of this. This thing's not working properly. So we're going to get rid of this one because this doesn't work properly anymore. Little Nepetiz. Yeah, I'm live streaming, but I got to get this done. It's really not much of a panel. After I get this done, we'll do a panel. It's an hour and a half to get this done. All right. So, Lab 5, applied, using storage encryption. Scenario: as a security team member of Structure Reality Inc., you are working to improve your organization's security stance. One area of concern is the protection of individual files using encryption and how to recover access to those files if necessary. In this lab, first you will configure an EFS data recovery agent, and then you will encrypt files with EFS. Next, you will break a user's accountability to access their EFS encrypted files. Finally, you will use a data recovery agent, DRA, to recover access to EFS encrypted files. You will work from a virtual machine named PC10 hosting Windows Servers 2019 configured as a client and connected to the internal client subnet. Objectives: this activity is designed to test your understanding of and ability to apply content examples in the following compTIA Security Plus objectives. 1.4, explain the importance of using appropriate cryptographic solutions. 2.5, explain the purpose of mitigation techniques used to secure the enterprise. 3.3, compare and contrast concepts and strategies to protect data. 5.1, summarize elements of effective security governance. Alrighty, well, let's look at resources real quick. All right, username admin, password. Cool. All right, configure an EFS data recovery agent. Storage encryption can be implemented in many ways, including full disk, partition, file, volume, database, and record encryption. This lab focuses on file encryption. Specifically, you will be using the encryption file system, EFS, which is a feature of the NTFS file format with Windows OS. Encryption file system, like most file encryption solutions, employs symmetric encryption to provide confidentiality protection for the files, and asymmetric encryption to store the symmetric encryption keys. Before you encrypt files with EFS, it is important to configure an EFS recovery agent first. Otherwise, encrypted files will be unrecoverable and inaccessible if the user's password is changed or if their encryption file system private key becomes corrupted. 1. Connect the PC-10 machines, then Control-Alt-Delete, sign in as Jamie password. Alrighty. So we'll go here, Control-Alt-Delete. Alright. We're signing as Jamie. We'll hit password. We'll enter in. You are signing in as Jamie since the account is a domain administrator and the default account for the PC-10 system. Once you remove PC-10 from the domain, you will use the local administrator account named admin. Click here. All right, we'll go to the search menu. I got to turn this sideways. Click here, type, or we can also just hit this thing. Bam, it will type PowerShell for us. Then we click up here, then right-click PowerShell, run as administrator. Yes. Alrighty. Enter the following code into Administrator Windows PowerShell console. Remove computer, unjoin domain credential administrator, restart force. This operation removes the PC-10 virtual machine from the domain and configures it as a standalone system. This is necessary for this lab in order to simulate the loss of an EFS private key, which is encryption file system key. The process used in this lab to remove the user's encryption file system private key does not work on a domain member. Okay. On the Windows PowerShell credential request window, type password as a password, then select OK. Okay, after a few seconds, the system will reboot. Connect to the PC-10 virtual machine, sign in as admin, password. Since the system is no longer a member of the domain, you must use local accounts. The local administrator account is named admin. All right, we're admin, passwords are password. Hit enter. All right, manually create an encryption file system data recovery agent certificate stored in a new folder named C drive folder certs. Expand this hint for guidance. You will not see any characters echoed in the command prompt window for the password after you type the password enter. This operation creates and saves the EFSDRI, the Electronic File System Data Recovery Agent, certificate as a file named EFSRA.CER, and a separate file named EFSRA.PFX, which contains the password protected private key for the EFSDRA certificate. The original name of the data recovery agent was Key Recovery Agent. However, some misunderstood the concept of the KRA, Key Recovery Agent, assuming it will restore access to the lost EFS private key, which the KRA, not the DRA, is unable to accomplish. The new DRA name clearly indicates this account is only able to restore the data access. Okay, so we did this. Alrighty, so then we have to go here. We'll type in PowerShell, right? We'll go up here. Well, oh shit, we were supposed to run as administrator. Damn it. Okay, go down here. PowerShell. All right, and again, we fucked up. PowerShell. Right click. Run as administrator. Yes. Okay, so now we will type C colon slash certificates. Enter. What term certificates is not recognized as the name of a commandlet function script file? Fuckery. Or Opera program. Check the spelling of the name, or if a path was included, verify that the path is correct and try again. Okay. Expand this hint for guidance. Command prompt. All right, not PowerShell. That's where we fucked up. Okay, so we'll click out of here. Okay, and we'll type CMD. Okay. Then we run as administrator. Oh, see that? Where that hint was there, because I was like, what the fuck do I do? I'm in PowerShell. I'm not supposed to be in PowerShell. I'm supposed to be in command prompt. Okay. So we did that. Select yes. Okay. Then create a folder, run the command, make DRI. So we'll type it in, MK, make directory. In the C drive, certificates. Enter. All right, now we will change directory to C drive certificates. Oh, we misspelled that. Enter. Alrighty. To create and export a certificate to be used for the encryption file system recovery agent activities, run the command cipher /r caps lock E FSRA. Enter. At the prompt to provide a password to protect the .px file, enter the standard password. So capital P, A, #, W0RD. Enter. We have to confirm it. P, A, #, W0RD. All right, your .ser file was created successfully. Your .pfx file was created successfully. All right, at the prompt, provide the password. All right, confirm password as password. To view the new certificate files, enter the command dir. dir. Enter. Oh shit. Okay. Alrighty, select score to validate this task. Alrighty, well, let's scroll up. Look at all that. Yep, there we go. Scrolling down. Alright, score. What the fuck? Okay, cipher. Flash R E F S R A. File certificate does not exist. Motherfucker. Because right here it says .ser.pfx was properly successfully corrected. Let's fucking do that again. Well, let's scroll up here. Let's go here. Already exists. Change drive. All right, now we're in certificates. Let's see if we change drive properly. All right, make drive certificates. All right, this system cannot find the path specified. Oh, because I fucking messed up. I misspelt it. F fuckery right there. You see this? I misspelt it. That's why. All right, let's fuck. Go back down. Okay. All right, switch. Now what the fuck? Okay. So we're in. Now we're in certificates again. Okay. Now we have to cipher here. Please type the password. Okay, we're just going to have it auto enter. Motherfucker. This is why it takes forever sometimes. P A number sign W 0 R D enter. P A number sign W 0 R D enter. All right, my passwords didn't match because I hit the fucking button too many times. I was supposed to hit enter after I type password over here. So then we will do this again. Alrighty, we'll hit this. 1,000, 2,000, 3,000. We'll hit enter. All right, we're supposed to hit enter. We'll hit password again. 1,000, 2,000, 3,000. We'll hit Enter. All right, now it's properly thing. Then we will type in directory. Okay, there we go. It's right there now. See, ta-da. Now we will score based upon the proper spelling. There we go. All right, both files exist. Okay, there we go. Add the EFS, the encryption file system, to the data recovery agent certificate to the local security policy. Expand this. Forget. All right. Select type here to search in the taskbar. Type mmc.exe. Run command from the results. Alrighty. mmc.exe. We'll go back up here. Alrighty. Do we right click? No, we just double click. Alright. The user account window will press yes. From the console 1 window, select file, then select add remove snap in. Oh. Okay. Alrighty, so here we go. From the console 1 window, select file. All right, add remove snap in. Where's add remove snap in? Alrighty, on the add or remove snap in window, select group policy object editor. Group policy object editor. I guess that's this one because it says group policy object, right? And then select add. On the select group policy object window, leave the default name of local computer, and select finish. Finish. Then select OK to close add or remove snap-ins. The local computer policy should now be displayed in the console 1 window. All right. Local computer policy, yep. In the left pane. I guess we can say this is left. In the left pane under computer configuration, we got to select it. Alrighty. In the left pane under computer configuration, double click the expand window settings. Double click. Alrighty. Security settings, public key policies, then select encrypting file systems. All right, so then we find security settings, and then we find public key policies, encrypt file systems, encrypting file systems. All righty, you may need to click, hold, and drag release the pane division to resize them. All right. This group policy has no encrypting file system policies defined directly on it. To define a policy, you can click on the encrypting file system node and select add data recovery agent from all the task menus. Alrighty. I got that swamp cooler blown on me. Okay. Right-click encrypting file systems in the left pane, then select Add Data Recovery Agent. Alrighty. On the Add Recovery Agent wizard window, select Next. On the Select Recovery Agent page, select Browse Folder. Alright, select the arrow to expand to this PC. Then select Local Disk C. Double-click the Certificates folder, select EFSRA, then select Open. This imports the public key file name. Alright, so we open this PC. It's open. Then select Local Disk. Alright, we did that. Then double-click the Certificates folder. Alrighty, select EFSRA folder, File. Oh, and then Open. I double-clicked it. Alright. This imports the public key file name EFSR cert. On the Add Recovery Agent window, select Yes. Yes. On the Recovery Agent wizard window, select Next. Then select Finish. You should see the admin certificate listed on the right pane. All right, there it is. All righty. Close Console 1 window, select No when prompted to save settings. Standalone non-domain joined Windows systems do not have a predefined data recovery agent, DRA. There's fireworks, hold on. All right. Standalone non-domain joined Windows systems do not have a predefined data recovery agent, DRA. A domain member Windows systems may or may not have a DRA defined. The DRA can recover EFS encrypted files in the event the original owner and encryptor of the file loses access or is removed from the computer or organization. In order for this recovery process to function, a DRA must be defined prior to the encryption of files. All right. Close console 1. Save? No. Okay. Create a new local user account named Pat with password 1. All right, you are assigning a unique password to the Pat account, which is not the lab standard password. You will also change this in a later exercise. All right. Run as administrator command prompt. Okay, so create the account. So administrator command prompt. There we are. All right, here we are. We'll click on that. And then we'll go like this. All right. Certificates, net user password. Added command completely successfully. All right. Well, let's go up here. We'll click on that. We'll click on this. We did get that. It took us a couple of tries. Confirm that yep, we did get that. Confirm you created a new local user account. New user password 1. All right, we're moving on. All right. Encryption file system is a native feature of the NTFS dot or NTFS. Encryption file system allows for individual files or entire folders to be encrypted without needing to encrypt an entire storage device or volume. EFS is easy to use both from the GUI utility as well from the command line. Sign out of PC10 by selecting the Start menu, then selecting Admin, which will be a circle at the top of the menu, then select Sign Out. If prompted that there are open programs, select Sign Out anyways. All right, sign out. Bam. Okay. I connect to PC10. Control Alt Delete. Then sign in as Pat. Pat. Enter password 1. Password 1. Okay. Create a text file named jan-security.txt in a new folder called C sec reports. All right, I got to expand this for hints because I don't know if I'm going to command line or PowerShell. It could be command line just because I'm just creating a file, right? File Explorer does not display known file extensions by default, so while you only provide the main file name of jan-security, the actual file name in the extension is jan-security.txt. Oh, okay. I was completely wrong. We don't use command line or PowerShell. We have to go here and we will type in File Explorer. File Explorer. Alrighty, into the Windows search bar, and then on the menu, select File Explorer. Alrighty, we will then select this PC, then double-click Local Disk. Alrighty, Local Disk. In the blank space of the file of the folder window pane, i.e., the right pane, right-click, select New, then select Folder. Okay, so here, right-click, New, Folder. Alrighty. Okay. Um, Enter Sec Reports, Security Reports. Alrighty. Double-click Security Reports. Right-click in an empty area. Go to New, Text Document. Enter Jan-Security. And we'll hit Enter. Okay, there we go. Alrighty. Create 2 additional text files named Feb Security, March Security, in the folder named Sec Reports. All right, so if we look up here on the top, all this stuff, where this PC local disk Sec Reports. Okay, so then we got to do 2 more. New, oops, new tech document. This one will be February Security. All right, and then we'll go new text document, March Security. Okay, in the Sec Reports folder, we will score this. All 3 files exist. Hoorah. All right. Open each of these new text files and enter. This is a security report. All righty, so we'll go here. and save each file. We'll expand this for hint guidance. Okay, double click, hit that, close Notepad, then select Save. Repeat these steps. Alrighty. Save. This is a security report. Then we click out. We save. This is a security report. Click out. Save. All right, we have done that. Okay. Using File Explorer, encrypt Jan security with the encryption file systems. All right, the encryption file system is configured by default to encrypt folders and the contents of those folders. When being used to encrypt individual files, you will be prompted to confirm or elect to encrypt the entire folder to which the current file is a member. You will receive a message about backing up your EFS key. You can ignore the message from this exercise. It will disappear after a few seconds, and when you select anything else on the desktop, However, it is a good idea to back up your EFS keys because if they are lost or corrupted, you will be able to access your encrypted files. You will be unable to access your encrypted files ever again unless you have a DRA defined who can restore your files to you, as will be performed in a later exercise in this lab. It may take 10 to 15 seconds for your EFS to encrypt the file. This is only because this is the first time EFS is being used on this drive, and the system configurations must take place. Subsequent encryptions will take less time. Alrighty, well, we're going to expand this for guidance. Alright. Right-click on the text file, jansecurity.txt. What the fuck just happened? Then select in the set folders. Oh, what the fuck is going on? What the fuck just happened? Retry connection. Oh, there we go. The connection lost. Okay. Alrighty, so we're in sec reports. Okay, right click, C drive, sec reports folders, and select properties. Okay, so we'll go to we'll go to properties. On the general tab, general, we will go down to advanced. All right, we click on advanced. Select the checkbox named encrypt contents to secure data. Encrypt contents to secure data. We checked it. Okay. Select OK to close the advanced attribute windows. Select OK to close the Advanced Security Properties windows. Alrighty, an encryption warning window will appear. Select encrypt the file only. Do not mark the checkbox. Do not mark the checkbox, and then select OK. All right. Select encrypt the file only. Encrypt the file only. Do not mark the checkbox, and then select OK. Okay, so this one, do not check that one, but select OK. So it may take 10 to 15 seconds. All right. One, two, three, four, five, six, seven, 8, 9, 10, 11, 12, 13, 14, 15. Anyways, right up here, it has that little thing, that little mark. I don't know if you guys can see it, but I can. It has a little lock on it. Okay. So we're going to. Alrighty. Check the status of the files in the C drive sec reports folder using the cipher command. And then encrypt February security and text March security using the command line. Expand for guidance. Okay. We'll go here. We'll click here. Type command, and then we will select command prompt. It's telling us just to go as command prompt, not run as administrator. So here we go. Okay, we will change drive to C sec reports. We are in C sec reports. Okay, the cipher command without parameters will display the contents of the current working directory along with an indication of the encryption status of each item. The E indicates the item is encrypted, while the U indicates the item is unencrypted. So, cipher. Alrighty, look at that. Encrypted, January and security. Unencrypted, February and March. Alrighty. To encrypt all files at once from the command prompt instead of the GUI, run the command cipher/e special thing /secure.txt. This command and parameter encrypt. The E is encrypt, so cipher encrypt the all security.txt files. Because that little star sign in the dash, the star stands for all, and then dash security.txt files. All right. This command and parameters encrypts all files matching the command all dash security wildcard in the current directory, which includes February security and March security. Encrypting files and sec reports. All right, okay. Two files or directories within one directories were encrypted. Converting files from plain text to ciphertext may lead to sections of old plain text on the disk volume. It is recommended to use command cipher to clean up the disk after all converting is done. Okay, check the status of the sec reports using cipher command, and then decrypt March security using the command line. Then view the status again. Enter. Oh shit! What the fuck happened? Okay, see, it shows that they're all encrypted over here. So so that way you guys can see without my face blocking it. Okay, so and then decrypt March using the command line. Okay, to view the encryption status of the objects, run the command cipher. All right. Note all three text files are now marked as encrypted. Yep, all three text files here. Okay, to decrypt, run the file cipher D March security instead of E. E means encrypt, D means unencrypt. This command and parameter decrypts the March security text files. One file were decrypted. Okay. To view the encryption status of the objects in the current working folder, run the command cipher. Notice that January security and March security text files are now marked as encrypted with the E, and March security text file is now marked unencrypted with the U. Okay, so here we go. EEU, yep, that's right. Close the command prompt window. Okay. Close command prompt window. Alrighty. See, there's this. All right. Click here. Okay, all proofs. All right. Configure File Explorer to display encrypted files as alternate colors. Notice the encrypted files and SEC reports are now color-coded to indicate that they are encrypted green and unencrypted black. Expand. File Explorer should be open. Yep. From the File Explorer menu, select View, then select Options. We'll go to View. Okay, and we got to go over here a little. View. Select it, scroll to Locate, and then select Show Encrypted. And then Options. Oh, Options is over in the corner. Options. Okay. Select View tab. View in here. Alrighty. And then in here, scroll to Locate and then select Show Encrypted or Compressed NTFS Files and Colors. All right, there we go, right here. Show Encrypted. Yep, we clicked it. All right, select OK to close File Options window. Okay. All right, bam. See, this is green, green, black. So encrypted, encrypted, not encrypted. Okay. Sign out of PAT 10 window. All right. Encrypted green, unencrypted black. Well, so we go down here. We go to PAT. All righty. Sign out. On the PC10 virtual machine, we will select the Control-Alt-Delete. Alrighty. We will change to admin, and we will enter the password. Okay. We will hit enter. Open File Explorer and view the contents of the CSEC reports. Notice that January security and February security text files have been locked yellow padlock. Have a locked yellow padlock icon over the file icon. This indicates this is an encrypted file. So we will go Open File Explorer, and we will go C drive sec reports, and we'll hit enter. All right, here we are. We will oh, motherfucker. There we go. All right, we have our little locked padlock, yellow locked padlock icon. Click there, click there, click there. All right. Attempt to open January security text by double-clicking its file name. A notepad warning is displayed indicating that you do not have permission to open this file. Select OK to close the warning, then close Notepad. If a how do you want to open this file windows appears, select Notepad, mark the checkbox, always use this app to open TXT files, and select OK. So we're going to January. Double click. All right, so how do you undo this? Always use Notepad. All right, mark checkbox, always use this app to open .txt files. Okay. All righty. You do not have permission to open this file. See the owner of the file or see the owner of the file or the administrator to obtain permission. Okay. Attempt to open file February. We'll click out of here. February. Double click. Alrighty, a notepad warning is displayed indicating you do not have permission to open this file. Select OK, then close notepad. Alrighty. Attempt to open March Security text file by double-clicking its file name. You are able to open this file as it is not encrypted, and the default inherent permissions granted the admin user at least read access. Close Notepad. The electronic or the encrypted file system can be used as means by which individual users can limit access to files and folders without the need to configure access control settings on those files and folders. Any user that does not possess the correct EFS key will be unable to access the EFS encrypted files. While EFS does hide the context or files from other non-authorized users, it does not hide the existence of or the name of the file. This is a security report. Alrighty. Confirm you switched users yet. Confirm you created text files yet. You had a contest, yes. Security report. Yep, did that. Confirm that you select File Explorer options. Yes. Confirm that you tested the access control aspect of ESS. That's them telling me to fuck off. Alrighty. Next. Break a user's accountability to access their own EFS encrypted files. When an administrator changes the password of a local user account, the EFS private key of that user account is discarded. Therefore, an administrator cannot use a password change as a means to access the encrypted files of a user. However, this does mean the user loses their ability to access the EFS encrypted files as well. Okay. We are signing here. We will close out of here. Sign in the PC10 send this. Then sign in as admin. We will see who we are. We'll sign out. Alrighty. Control Alt V. Admin. All right. We're an admin. Type password as password. Change the password of Pat to password 123 using the command prompt. You are logged out of the Pat account on PC10, which ensures that the password change will also replace the encrypted file system key assigned to the account. So we'll type in command CMD, and we'll run as administrator. Select run as administrator, yes. Alrighty, we're going to okay. All right, change the password to pad 123. All right. Command line, right click, run as administrator. Yes. Type net user password 123. All right, there will be no confirmation. Oh, I just got one. The command completed successfully. You are logged out of the Pat account on PC10. Ensures that the password change will also replace the EFS count. Sign out of the admin password. Sign out of admin PC10. Okay, so we'll scroll down here. We'll click here. We'll go up here. We'll select sign out. I'm fucking hungry, yo. Okay, we'll do Control Alt Delete. Alrighty, and sign in as Pat. We'll click on Pat. All right, password for Pat is password 1. We'll hit enter. Notice the error message starting that the password is incorrect. Select OK. Then sign into Pad account using password 123. Bam, it worked because the password got changed. Select OK. Open File Explorer to view the contents of C File Explorer, and we'll type in C sec reports. Yep. We'll double click that. Alrighty. We'll scroll up. Alrighty. Attempt to open January Security by double clicking its file name. A notepad warning is displayed indicating you do not have permission to open this file. Select OK to close the warning, then close Notepad. Okay, we'll go to January Security. You do not have permission. Hit OK. Close Notepad. Attempt to open February. By double clicking it, a notepad warning is displayed. We'll select OK to close the warning, then we'll close the notepad. Alrighty. Attempt to open March Security by double clicking March Security. You're able to open the file as it is not encrypted and therefore not affected by the account's loss of the EFS key. Close Notepad. Why is the PAT account no longer able to open their encrypted files? The files are owned by another account. The administrator forcibly changed their passwords. Encrypted files can only be opened during working hours. They are signed into the wrong computer. Is it this one? Yes, the administrator forcibly changed their passwords. All right, sign out of PAT from PC 10. Okay, so we'll go here. Pat, sign out. Okay, we are signed out of PC 10. Okay, click there. Confirm that you changed a user password via command prompt. That's what we did. Confirm that you verified that Pat user account has lost access to their encrypted files. Yep. Okay, we got a half hour to go and a quarter of the thing to complete. Alrighty. Use a data recovery agent, DRA, to recover access to the EFS encrypted files. If a user has lost access to their EFS private key, they are no longer able to open their encrypted files. If there was a defined DRA when the files were encrypted, the DRA may be able to restore access to the files to the user. All right, on PC 10, we'll go Control-Alt-Delete. And we will sign in as admin. All right, admin's password is password. Enter. Attempt to decrypt January security text file using the cipher command, then use the cipher command to display information about the encrypted file. Alrighty. We'll go to taskbar. We'll type CMD. Then we will right click and run as administrator. Alrighty, here we go. Okay. Select yes in the user account control window. We will change directory to sec reports. Attempt to decrypt this thing by decrypt. Notice the results are that an error occurred. No files were decrypted. Error. This specific file cannot be decrypted. Alrighty. Run the command cipher C security text. New files added to this directory will not be encrypted. Compatible level, here. Certificate thumbprint, there. Recovery certificates for admin, there. Key information cannot be retrieved. The special. Alrighty. Review the information about the file. All right. Notice the display indicates that admin is the designated recovery certification entity. All right. Recovery certificates right here. That's this. All right. However, the reason the attempt to decrypt the file failed as that the private key of the ECA-DRA has not been imported. Thus, without that private key, the DRA function cannot take place. Install the EFSRA.pfx private key. The default configuration of Windows hides file extensions. Double-clicking EFSRA.cer will open a certificate window displaying the details of the certificate rather than the expanded certificate import wizard. If this occurs, close the certificate window and double-click the other file, which therefore would be EFSRA.pfx. Alrighty. Open File Explorer. Okay. Oh, wait, no. Oops. File Explorer is this one. We'll scroll up. We'll select this PC. Okay. Double click local disk. We gotta scroll down. Double click. Alrighty. Double click the certificates folder. Alrighty, there we are. Okay. Double-click the EFSRA file, which is labeled as being the type personal information exchange. No, this label may be truncated to personal information. Wear a shirt, Jeebus. I'm wearing socks and shorts. Good enough. And boxer briefs. It's fucking hot out, yo. Okay. This label may be truncated to this, which has an icon of a document extended out of an envelope with a yellow key overlaid. All right, I see that. That's this bottom one because there's the envelope with a yellow key overlaid. This opens through the certificate import window. And right here, you see it says the personal information exchange. All right, that's the one. So we double click this. Alrighty. This opens the certificate import wizard. Bam, that's that. Alrighty. Leave the default section of current user, then select next. Current user, select next. All right, leave the default file name, C drive / certificate / EFSRA.pfx, then select next. All right, then we will enter password as the password field. Leave all settings at their default, then select next. All right, we leave the settings. We select next. All right. Leave the default section of automatically select the certificate stored based on the type of certificate, then select next and select finish. All right, we leave that. We select next. Then we select finish. Alrighty. On the certificate import wizard notification that the import was successful, select OK. OK. Run the command prompt and attempt to decrypt January TXT using the cipher command. Notice this time the operation is successful and display a message stating one files or directories within one directory were decrypted. So we go back to here. Let's scroll up. So I think we just go like this. Bam. All right. Oh, shit. Was that the right one? We're decrypted. So now we go down here, and it says notice this operation. Oh, shit. I think we ran the wrong one. We need the D, not the C. There it is. That's the one we need with the D. Alrighty. We'll hit that. Okay, there it is. Decrypting files. All right. One files are directories within one directory were decrypted. There we go. Okay. Using the cipherman to view the encrypted status. Okay, so we will run the cipher command of this, right? To view the encryption status of the current folder's file. U, unencrypted January security.txt. All right, notice that January text is now listed as unencrypted, marked with a U. This means as a DRA, you have recovered access to an encrypted file after the original user lost their decryption capabilities. Remember that is originally encrypted by Pat, but you are currently logged in as admin. But as the encryption file system DRA, your private key, with your private key installed, you were able to decrypt files from other users. View the details about encryption on February security through the File Explorer. Then use the GUI method to decrypt the file. The File Explorer window focus on sec report should be that February security text is no longer encrypted. Return to File Explorer. Select PC. All right. And we want security reports, sec reports. Okay. Right click February, then select Properties. Alrighty. Go to Advanced. Then we're going to go to Details. Alrighty. The user access for February security window displays the users who have access to the file. In this case, only Pat. All right, there we are. It says only Pat right here. Only Pat right there. PC Pat at PC 10. Okay. Displays user of the file. In this case, only Pat, as well as the recovery certificates. In this case, that of admin. That's down at the bottom, okay? Recovery certificates for this file as defined by the recovery policy, recovery certificate admin at PC 10. There it is. Select OK to close this window. Deselect the checkbox named Encrypt Contents to Secure Data. Deselect. Then select OK. Then select OK again. All right, you may be prompted by an access denied window. You will need to provide administrative permission to change these attributes. Select Continue. Alrighty, we hit continue. Alrighty, the access denied window is an element of user account control. Even though you are logged in with administrator privileges, the system is configured by default to display the user access control warning. By selecting continue, you are verifying that you understand the activity being attempted will be using administrative privileges. All right. Score. Okay, January security text message is decrypted. Same with February security. Sign out of admin of PC10. PC10, sign out. Alrighty, we will sign out. On PC10, we will sign in as Pat. Okay. We will click on Pat. Alrighty, we will enter password 123. Hit enter. Okay, we're now in. Open File Explorer. That's here. Alrighty, to view C drive sect reports. Notice all files in this folder are no longer encrypted. So we'll go to PC. Oh, it's right here. But these show they are recent files. So we will go here. Alrighty. We will go to sec reports. All right, bam. They're no longer encrypted. You see that? Notice all files in this folder are no longer encrypted. Local drive sec reports no longer encrypted. Okay. Open and view the contents of each text file using Notepad. This confirms that the EFS-DRA was able to recover data files on behalf of the user that lost access to their own EFS private key due to admin changing their password. An encryption file system data recovery agent is able to decrypt files in order to return them to an accessible state. This capability is useful in situations where the user's EFS private key is damaged, lost, or discarded, such as when an administrator changes their password. The ability of an encryption file system data recovery agent to decrypt files can also be useful in recovering files encrypted by a user account that has been deleted or by a user who refuses to cooperate with management or investigators. All right, we'll check. All right, we're in. We're in. We're in. All right, check. Okay, confirm that you installed the PIX key in order to function as a data recovery agent. That's what we did. Confirm that you decrypted a file as the data recovery agent from a command prompt and through the GUI. Yep. Confirm that you viewed a file's encryption status. Yep. That's what we did. Okay. Bam. All right. Here's the testing of it all. Okay, comprehensive questions. Each assistant lab ends with a set of comprehensive questions. Answer these to ensure that you recognize the importance of the activity steps and the users for the information you have learned. A DRA is able to perform what tasks? Recover access to data that a user had encrypted with the encryption file system? Yes. Restore files from a damaged storage device? No. Recover access to a user's EFS private key? Maybe. Restore deleted files from backup? No. We know this no matter what. Recover access to data that a user had encrypted with the electronic file, encryption file system. Okay, so it was only one answer. Alrighty. What is the command used to encrypt a file from the Windows command line? Cipher encrypt. Cipher/E. All right. Where can a user encrypt a file in Windows? Command prompt, PowerShell, and File Explorer. Bam. Okay. A data recovery agent can be defined or established after a file is encrypted, and they can still recover access to the plain text file if needed. True. Oh, Yes, that's false. I'm confused on that one. All right. The EFSRA.pfx file, which was imported into the system before the data recovery agent was able to restore the plain text versions of the file, contain what? Oh, you motherfucker, I just lost fucking fuckery again. Oh my god, dude. Luckily, I got 18 minutes remaining and I gotta wait a fucking minute for the connection to reinstitute. All right, there we go. All right, there we go. All right, so I think it's the bottom one. All right, so the private key of the DRA, maybe. The public key, irrelevant. The symmetric key encrypting the file, the symmetric key, the asymmetric key encrypting the storage device. It's not the storage device. It may be the symmetric key encrypting the file. No, we'll go with the private key of the DRA. All right, so it was the first one. That's kind of what I thought. So those bottom ones were a little because the last one that says asymmetric key encrypting the storage device, no, it's not the storage device because it's the file. So that's why I got confused with the symmetric key encrypting the file. No, we're just getting the private key of the data recovery agent. Bam. Grade lab. Okay, this concludes this lab. When you have finished a lab, please ensure you end it properly rather than just closing the browser window. Once you select submit, you will not be able to return to this lab instance. However, if you want to repeat the lab, you can launch a new instance from your lab portal. Alrighty, and then at the bottom, you can use this to save, end, or split windows. Okay, we're not going to save it and we're not going to end it because we have plenty of time. All right. You can also use the menu button to cancel a lab. Ending a lab means that no score will be recorded, and the next time you launch a lab, it will be reset to its original starting conditions, basically doing it all over again. All right. So make sure you have submitted responses to all of the scored activities we have. Select submit below to grade the lab. Bam. Submit. Are you sure you want to submit for grading? Yes. All right. There we go. Okay. So that took us an hour and 17 minutes. In our live stream, and we had 15 minutes left over from an hour and a half, so that was an hour and 15 minutes. Okay, so we'll click on this because we always do, and then we click on cancel. Alrighty, now we close out of this browser. Okay, and now here we will go back to our learning plan. All right, we just commit. Okay, I thought we just did that, so we will restart this to see if 4 out of 12 is still there. We should be on 5 out of 12. We just did 4 out of 12. Yep, there it is. 5 out of 12. Okay. So this is a topic, all right? We're going to do this topic right now and get it done. Public key infrastructure. Yep, which is right up here. Public key infrastructure, topic 3B. Topic 3B, public key infrastructure. Oh, this is where we look at and read, all right? Oh, there's 10 of these. Topic 3B, public key infrastructure. Exam objectives covered for 1.4 explain the importance of using appropriate cryptographic solutions. Public key infrastructure, PKI, is the framework that helps to establish trust in the use of public key cryptography to sign and encrypt messages via digital certificates. A digital certificate is a public assertion of identity validated by a certificate authority. As a security professional, you are very likely to have to install and maintain public key infrastructure certificate services for private keys. You may also need to obtain and manage certificates from third-party private key infrastructure providers. This topic will help you to explain the importance of using appropriate cryptographic solutions to implement a PKI. Rate your confidence? Dick pill level of confidence, motherfuckers. Certificate authorities. Public key cryptography solves the problem of distributing encryption keys when you want to communicate securely with others or authenticate a message that you send to others. When you want others to send your confidential messages, you give them your public key to use to encrypt the message. The message can then only be decrypted by your private key, which you keep known only to yourself. All right. I was reading ahead and not speaking out loud. So hold on. Let me get back to okay. Certificate authorities. Public key cryptography solves the problem of distributing encryption keys when you want to communicate securely with others or authenticate a message that you send to others. When you want others to send your confidential messages, you give them your public key to use to encrypt the message. The message can then only be decrypted by your private key, which you keep known only to yourself. When you want to authenticate yourself to others, you sign a hash of your message with your private key. You give others your public key to use to verify the signature. As only you know the private key, everyone can be assured that only you could have created the signature. The basic problem of public key cryptography is that while the owner of a private key can authenticate messages, there is no mechanism for establishing the owner's identity. This problem is particularly evident with e-commerce. How can you be sure that a shopping site or banking service is really maintained by who it claims? The fact that the site is distributing a public key to secure communications is no guarantee of actual identity. However, you do know that you are corresponding directly with the site using its genuine public key. How can you be sure there isn't a threat actor with network access intercepting and modifying what you think the legitimate server is sending you? Public key infrastructure (PKI) aims to prove that the owners of public keys are who they say they are. Under public key infrastructure, anyone using a public key should publish it in a digital certificate. The certificate's validity is guaranteed by a certificate authority. PKI public key infrastructure can use private or third-party certificate authorities. A private certificate authority can be set up within an organization for internal communications. The certificate it issues will only be trusted within the organization for public or business-to-business communications. A third-party certificate authority can be used to establish a trust relationship between servers and clients. Examples of third-party certificate authorities include Komodo, Digicert, GeoTrust, IdenTrust, and Let's Encrypt. Alrighty. One here. Certificate authority generates a root certificate, signs it with a private key, and publishes it with the public key. Two, there's certificate authority with the certificate authority public key. Client obtains certificate authority certificate and adds it to a store of trusted root certificates. Um, Three, web server creates a certificate signing request containing its public key and submits it to the certificate authority. Certificate signing request with web server public key goes to four. The certificate authority generates a signed certificate from the certificate signing request and returns it to the web server. Web server certificate with web server public key goes to 5. Client checks web server certificate and validates that it is signed by a trusted certificate authority. 6. Client and server establish a trusted and encrypted connection. Ta-da! Public key infrastructure allows clients to establish a trust relationship with servers via certificate authorities. The function of a third-party public certificate authority are as follows. Provide a range of certificate services useful to the community of users serviced by the certificate authority. Ensure the validity of certificates and the identity of those applying for them registration. Establish trust in the certificate authority with users, governments, regulatory authorities, and enterprises such as financial institutions. Manage the servers, repositories that store and administer the certificates. Perform key and certificate lifecycle management, notably revoking invalid certificates. Rate your confidence, dick pill level of confidence, motherfuckers. Alrighty, it's 12:18. We gotta finish this because I gotta eat some food. Digital certificate. A digital certificate is essentially a wrapper for a subject's public key, as well as the public key. It contains information about the subject and the certificate's issuer. The certificate is digitally signed to prove that it was used to the subject by a particular CA. The subject could be a human user for certificates allowing the signing of messages, for instances, or a computer server for a web server hosting confidential transactions, for instances. For instance, all right. Digital certificates are based on the X.501 standard approved by the International Telecommunications Union and standardized by the Internet Engineering Task Force. RSA also created a set of standards referred to as public key cryptography standards (PKCS) to promote the use of a public key infrastructure. The root of trust model defines how users and different CAs can trust another. Each CA uses a certificate. This is referred to as root certificate. The root certificate is signed, meaning the CA server signs a certificate issued to itself. A root certificate uses an RSA key size of 2048 or 4096 bits, or the ECC equivalent. The subject of the root certificate is set to the organization CA name, such as compTIA root CA. The root certificate can be used to sign other certificates used by the CA. Installing the CA's root certificate means that hosts will automatically trust any certificate signed by the CA, single CA. In this simple model, a single root CA issues certificates directly to users and computers. This single CA model is often used on private networks. The problem with this approach is that the single certifying authority, certificate authority server is very exposed. If it is compromised, the whole PKI collapses. Third-party certificate authorities. Most third-party certificate authorities operate in a hierarchical model. In the hierarchical model, the root certificate authority issues certificate to one or more intermediate CAs. The intermediate CAs issue certificates to subjects, leaf or N entities. This model has the advantage that different intermediate certificate authorities can be set up with certificate policies enabling users to perceive clearly what a particular certificate is designed for. Each leaf certificate can be traced to the root certificate authority along with the certification path. This is also referred to as certificate chaining or a chain of trust. Alrighty. Description. The web server for example.org is identified by a certificate issued by the DigiCert TLS CA1 intermediate CA. The intermediate certificate authority certificate is signed by DigiCert's global root CA screenshot used with permission from Microsoft. self-signed certificates. In some circumstances, using PKI can be too difficult or expensive to manage. Any machine, web server, or program code can be deployed with a self-signed certificate. For example, the web administrative interfaces of consumer routers are often only protected by a self-signed certificate. Self-signed certificates can also be useful in development and test environments. The operating system or browser will mark self-signed certificates as untrusted, but a user can choose to override this. The nature of self-signed certificate makes them very difficult to validate. They should not be used to protect critical hosts and applications. Thick pill level of confidence. Alrighty. Certificate signing request. Registration is the process by which end users create an account with the CA and become authorized to request certificates. The exact process by which users are authorized and their identity proven are determined by the certificate authority implementation. For example, in a window domain network, users and devices can often auto enroll with the certificate authority just by authenticating the Active Directory. A third-party CA might perform a range of tests to ensure that a subject is who they claim to be. It is in the CA's interest to ensure that it only issues certificates to legitimate users, and its reputation will suffer. When a subject wants to obtain a certificate, it first generates a key pair comprising private and public asymmetric keys for the chosen cipher, such as RSA or ECC and key length. The private key must be kept well protected and known only to the subject. The subject then completes a certificate signing request, CSR, and submits it to the CA. The CSR is a file containing the information that the subject wants to use in the certificate, including its public key. The CA reviews the certificate and checks that the information is valid for a web server. This may simply mean verifying that the subject name and fully qualified domain name (FQDN) are identical, and verifying that the CSR was initiated by the person administratively responsible for the domain as identified in the domain's WHOIS record. If the request is accepted, the certificate authority signs the certificate and sends it to the subject. Using a web form on the OpenSense Firewall appliance to request a certificate, the DNS and IP alternative names must watch the values that clients will use to browse the site. All right. Subject name attributes. When certificates were first introduced, the common name (CN) attribute was used to identify the fully qualified domain name by which the server is accessed, such as compTIA.org. This usage grew by custom rather than design. However, the CN attribute can obtain different kinds of information, making it difficult for a browser to interpret it correctly. Consequently, the common name attribute is now depreciated as a method of validating a subject identity that needs to resolve to some type of network address. The subject alternative name (SAN) extension field is structured to represent different types of identifiers, including FQDNs and IP addresses. If a certificate is configured with SAN, the browser should validate that and ignore the CN value. Description: the example domain certificate is configured with alternative subject names for different top-level domains and subdomains. It is still safer to put the FQDN in the CN as well, because not all browsers and implementations stay up to date with the standards. The SAN field also allows a certificate to represent different subdomains, such as compTIA.org and members.compTIA.org. Listing the specific subdomains is more secure. When a new subdomain is added, a new certificate must be issued. In wildcard domains, such as star.comptia.org, means that the certificate issued to the parent domain will be accepted as valid for all subdomains to a single level, such as this right there. Description. compTIA's website certificate configured with wildcard domain allows access via either https comptia.org or https comptia.org. Oh, www.comptia.org. Screenshots used with permission from Microsoft. A certificate also containing fields for organization O, organizational unit OU, locality L, state ST, country C. These are concatenated with the common name to form a distinguished name DN. For example, example LLC's DN would be the following: CN common name equals www.example.com. The organizational unit, web hosting, the organization, example LLC, the location is Chicago, the state is Illinois, and the country is US. Different certificate types can be used for purposes other than server computer identification. User accounts can be issued with email certificates, in which case the SAN is an RFC822 email address. A code signing certificate is used to verify the publisher or developer of software and scripts. These don't use a SAN, but the CA certificate authority must validate the organization and locate details to ensure accuracy and that a rogue developer is not attempting to impersonate a well-known software company. Certificate revocation. A certificate may be revoked or suspended. A revoked certificate is no longer valid and cannot be unrevoked or reinstated. A suspended certificate can be re-enabled. So a revoked certificate, no longer valid and cannot be unrevoked or reinstated. A suspended certificate can be re-enabled. A certificate may be revoked or suspended by the owner or by the certificate authority for many reasons. For example, the private key may have been compromised, the business could have closed, a user could have left the company, a domain name could have been changed, their certificate could have been misused, and so on. The reasons are codified under choices such as unspecified key compromise, certificate authority compromise, superseded, or cessation of operation. A suspended key is given the code certificate hold. There must be a mechanism to inform users whether a certificate is valid, revoked, or suspended. A certificate authority must maintain a certificate revocation list, CRL, of all revoked and suspended certificates. The certificate revocation list must be accessible to anyone relying on the validity of the certificate authority certificates. Each certificate should contain information for the browser on how to check the certificate revocation list. Description. The distribution point field in a digital certificate identifies the location of the list of revoked certificates which are published in the CRL file signed by CA. There we go. The CRL has the following attributes. Publish period. I don't see that up there. All right, publish period. The date and time on which the CRL certificate revocation list is published. Most certificate authorities are set up to publish the certificate revocation list automatically. Distribution points, the locations to which the certificate revocation list is published. Validity period, the period during which the CRL is considered authoritative. This is usually a bit longer than the published period. For example, if the published period was every 24 hours, the validity period might be 25 hours. Signature. The certificate revocation list is signed by the certificate authority to verify its authenticity. With the certificate revocation list system, there is a risk that their certificate might be revoked but still accepted by clients because an up-to-date certification revocation list has not been published. A further problem is that the browser or other application may not be configured to perform CLR checking. although this now tends to be the case only with legacy browser software. Another means of providing up-to-date information is to check the certificate status on an online certificate status protocol server. Rather than return a whole CRL certificate revocation list, this communicates requested certificate status. Details of the online certificate status protocol responder service should be published in the certificate. Most online certificate status protocol servers can query their certificate database directly and obtain the real-time status of a certificate. Other online certificate status protocol servers actually depend on the CRLs and are limited by the CRL publishing interval. Bam. Rate your confidence, dick pill level of confidence. Continue. 8 out of 10. Key management. Key management refers to the operational considerations for the various stages in a key's lifecycle. A key's lifecycle may involve the following stages. Key generation. Creates an asymmetrical key bearer or symmetric secret key of the required strength using the chosen cipher. Storage. Prevents unauthorized access to a private or secret key and protecting against loss or damage. Revocation. Revocation prevents use of a key if it is compromised. If a key is revoked, any data that was encrypted using it should be re-encrypted using a new key. Expiration and renewal. Gives the certificates a shelf life, increasing security. Every certificate expires after a certain period. Certificates can be renewed with the same key pair or with a new key pair. A decentralized key management model means that keys are generated and managed directly on the computer or user account that will use the certificate. This does not require any special setup and is easy to deploy. It makes the detection of key compromises more difficult, however. Some organizations prefer to centralize key generation and storage using a tool such as key management system. And one type of cryptographic key management system, a dedicated server or appliance, is used to generate and store keys. When a device or app needs to perform a cryptographic operation, it uses the key management interoperability protocol, KMIP, to communicate with the server. Rate your confidence, dick pill level of confidence. Crypto processors and secure enclaves. A key pair or secret key can be generated and stored in the file system on a desktop or server computer running a general purpose OS. This has a number of drawbacks, however. A cryptographic key needs to be generated using a random process. A key generation system with a higher degree of disorder or entropy a measure of disorder. Cryptographic systems should exhibit high entropy to better resist brute force attacks. A key generation system with a high degree of disorder or entropy ensures that any value from the possible key space has the same chance of being selected as any other. Unfortunately, computer hardware and software is extremely low entropy. Computer process instructions in an entirely deterministic way. A computer can use pseudo RNG, PRNG software that is still deterministic but able to approximate a high level of disorder. Better security is obtained by true random number generator, PRNG hardware. This uses a source of entropy, such as noise or air movement, as a non-deterministic seed for generating the key value. A key stored in the file system is only as secure as any other file. It could easily be compromised via the user credential or physical theft of the device. It is also difficult to ensure that key access is fully audited. Ideally, cryptographic storage is tamper evident. This means that it is known immediately when a private or secret key has been compromised and it can be revoked and any ciphertext re-encrypted with a new key. We need to generate a lot of random bytes. It is a good idea. Pseudo ring working during key generation using GPG. This method gains entropy by using from user mouse and key usage. These drawbacks can be addressed by using a crypto processor for key generation and storage. Because it is dedicated to a single function, the crypto processor hardware has a smaller attack surface than a general purpose computer. A crypto processor can also perform operations such as decryption and signing on behalf of apps. This means that the key material never leaves the crypto processor. There are two main ways of implementing crypto processor hardware: TPMs and HSMs. TPMs, a trusted platform module, is a crypto processor implemented as a module for a discrete computer platform such as a desktop computer, mobile device, or embedded system. TPMs are produced to different 1.2 and 2.0 versions specifications. Version 2.0 is not backwards compatible with 1.2. Most vendors depreciate version 1.2, as well as supported as well as the supported version. There are three principal ways of implementing TPM. Discrete means that the TPM is implemented as a dedicated chip. This provides tamper resistance and the smallest attack surface. Integrated means that the TPM is part of a chipset or CPU that performs other functions. This implementation is not tamper resistant and has a broader attack surface. Firmware means the TPM is implemented in the platform's low-level operating code. This depends on the secure enclave function of the CPU or chipset to protect the cryptographic material. Examples of these include Intel's Platform Trust Technology, PTT, and AMD's FTPM. This implementation is not tamper resistant and has the broadcast attack surface encompassing the code underpinning the CPU or chipset secure enclave functionality. A virtual TPM can be implemented in a hypervisor to provide a service to virtual machines, VMs. HSM, Hardware Security Model. A hardware security module is crypto processor hardware implemented in a removable or dedicated form factor, including rack-mounted appliances, plug-in PCIe adapter cards, and USB-connected security keys. It is also possible to provision an HSM as a virtual appliance, where a TPM is designed to validate the security of a discrete computing platform, such as a desktop computer or laptop. And HSM provides either centralized key storage for network hosts or portable key storage that people can use on different devices. Hardware security module. Hardware security module appliances in a rack mounted form factor. Vendors can certify their products establish Vendors can certify their products against the Federal Information Processing Standard 140 Level 10, FIPS 140-2, or Level 2, to establish trust in the market. Secure enclave. Using a crypto processor means that keys are not directly accessible via the file system. The crypto processors interacts with applications that need to access the key via an application programming interface (API) that implements PKCS number 11. One vulnerability in the system is that the decrypted data needs to be loaded into the computer system memory (RAM) for applications to access it. This raises the potential for a malicious process to gain access to the data via some type of exploit. This vulnerability can be mitigated by implementing a secure enclave. A trusted execution environment (TEE) secure enclave, such as Intel Software Guard extensions, is able to protect data stored in system memory so that an entrusted process cannot read it. A secure enclave is designed so that even processes with root or system privileges cannot access it without authorization. The enclave is locked to a list of one or more digitally signed processes. Dick pill level of confidence. All right, here we go. It's 12:42, and I need a fucking eat. Key escrow. If a private key or secret key is lost or damaged, ciphertext cannot be recovered unless a backup of the key has been made. Making copies of the key is problematic as it becomes more likely that a copy will be compromised and more difficult to detect that a compromise has occurred. These issues can be mitigated by using escrow and M of N controls. Escrow in key management, the storage of a backup key with a third party means that something is held independently. In terms of key management, this refers to archiving a key or keys with a third party. M of N means that an operation cannot be performed by a single individual. Instead, a quorum M of individual persons N must agree to authorize the operation. A key can be split into parts. Each part can be held by separate escrow providers, reducing the risk of compromise. An account with permission to access a key held in escrow is referred to as a key recovery agent, KRA. A recovery policy can require two or more KRAs to authorize the operation. This mitigates the risk of a KRA attempting to impersonate the key owner. Alrighty. Uh, 14-point review activity, public key infrastructure. Let's fucking do it. How does a subject go about obtaining a certificate from a certificate authority? They have to apply and give all their information. In most cases, the subject generates a key pair, adds the public key along with subject information and certificate type in a certificate signing request, and submits it to the certification authority. If the certification authority accepts the request, it generates a certificate with the appropriate key usage and validity, signs it, and transmits it to the subject. Apply, and they have to give, I'll say kind of. What cryptographic information is stored in a digital certificate? Um, all the shit we just talked about. The subject's public key and the algorithms used for encryption and hashing. Their certificate also stores a digital signature from the issuing CA establishing the chain of trust. I'm giving myself one. That one. All right. What extension field is used with a web server certificate to support the identification of the server by multiple certificate subdomains? That's that little star. I don't know how to answer this one. The subject alternative name, Sandfield. A wildcard certificate will match any subdomain level. The wildcard is a little star. I'm giving myself that one. What are the potential consequences if a company loses control of a private key? Everything. Their whole system is compromised. It puts both data confidentiality, identification, and authentication systems at risk. Depending on the key usage, the key may be used to decrypt data without authorization. The key could also be used to impersonate a user or computer account. Yeah. You are advising a customer about encryption for data backup security and the key escrow service that you offer. How should you explain the risk of key escrow and potential mitigations? Um, a key escrow is a third party, and they could require you plus them to use it, which helps potentially mitigate attacks. Escrow refers to archiving the keys used to encrypt the customer's backup with your company as a third party. The risk is that an insider attack from your company may be able to decrypt the data backups. This risk can be mitigated by requiring M&N, yep, a group, access to the escrow keys, reducing the risk of a rogue administrator. What mechanism informs clients about suspended or revoked keys? That's the CRL, the Certificate Revocation List. Either a published certificate revocation list, CRL, or an online certificate status protocol responder. You are providing consultancy to a firm to help them implement smart card authentication to premise premises, networks, and cloud services. What are the main advantages of using HSM, a hardware server module, over service-based key and certificate management system? Um, it's hardware in your location. That's a tricky question. I don't understand it. A hardware security module is optimized for this role and so presents a small attack surface. It is designed to be tamper evident to mitigate against insider threat risk. It is also likely to have better implementation of a random number generator, improving the security properties of key material. We'll give myself kind on that one, even though I think I should give myself a yes. Alrighty. Um, fuck it. We'll keep going. Cryptographic solutions. Study task. Oh my fucking god, dude. Alrighty. Type C. Fuck. Alright, we gotta do it. Type C. Topic 3C. Cryptographic solutions. Exam objectives covered. 1.4. Examine the importance of using appropriate cryptographic solutions. I gotta eat. I'm gonna call it, dude. I'm fucking starving. It's basically 12:48 p.m. I'm fucking hungry as fuck. Yeah, everybody in YouTube land, stay warm for you, stay warm, stay cool for you, stay cool, stay healthy, stay safe, stay sober for choosing sobriety because I'm choosing sobriety. Peace. Love you. We'll stop screen and broadcast quick and broadcast.